Hello students, today in this class we will learn about Ohm's law. Last class we have seen about Ohm's law. Okay, so today we will define Ohm's law and we will continue. So what is Ohm's law? Statement says that V is directly proportional to I at constant temperature. So what is V? V is voltage or potential difference. So the potential difference across the terminals of a conductor is directly proportional to the current flowing through the circuit provided the temperature remains constant. Or in other words you can say at constant temperature the potential difference across the terminals of a conductor is directly proportional through the electric current flowing through it. Okay. So that proportionality symbol is replaced by equal to symbol. Okay, then a constant R will come here. So V equal to R or V equal to IR. So this is the Ohm's law formula. So voltage, you know, potential difference. This is current. So voltage is measured by voltmeter. Current is measured by ammeter. SI unit of voltage is volt. SI unit of current is ampere. Now we learn about this resistance. So what is R? Here R is resistance. What is the resistance? See, resistance is nothing but the opposition offered to the flow of current. There is a flow of current, but some quality present in conductor that resists the flow of current, flow of electrons. For example, if you are standing in a river, the water is flowing this side, you are moving this side, that means you are opposing the flow of water. So, you are opposing the flow of water means you are resisting the flow of water, that is you are resistance there. Similarly, if you are moving in a bike in high speed, suddenly road brake comes, what happens? You will slow down the bike. That road brake is the resistance. So whatever bike you are moving, that is the flow of current. That road brake is resistance. Similarly, the flow of current is being resisted, it's been opposed. That is resistance. Let's say what is resistance? Resistance is the opposition. Opposition. Define resistance. If anybody asks define resistance, you have to say resistance is opposition offered to the flow of current. Opposition offered to the flow of current is called resistance. Opposition offered to the flow of current is called resistance. Okay, resistance is what? This is the opposition offered to the flow of current is resistance. Means it is opposing the current. It is opposing the current means obviously it is inversely proportional to the current. So inversely proportional to the current. What is inversely proportional means? As the resistance increases, current decreases. As the resistance decreases, current increases. Just exactly reverse to the electric current. If current increased, then resistance will decrease. If resistance decrease, then current will increase. If resistance increases, current will decreases. So this is about resistance. So what is resistance? Resistance is opposition offered to the flow of current. Okay. Then resistance is represented by SI unit of resistance is we call it as ohm. So this is the symbol. You have to say it as ohm. Why it is ohm? Ohm is the first scientist who has given more knowledge or more discovery on resistance. So for that purpose we are using ohm as the SI unit of resistance. This is the symbol. You have to write like this. Suppose resistance of 10 ohm means you have to write 10 ohm like this. Suppose resistance of 25 ohm, 25 ohm has to be written like this. Okay. This is called ohm. This is the symbol and it should be pronounced as ohm. Okay. So this is regarding resistance. Okay. So based on resistance, materials are classified on conductors, insulators and semiconductors. Based on resistance of a material, materials are classified. So conductors, what are conductors? Okay, what are conductors? Suppose a material, let me take a copper wire is here. So all materials are either conductor, insulator or semiconductor. Copper wire. Copper wire is a good conductor of electricity. Why it is a good conductor of electricity? Because it is a conductor of electricity. That means conductor's resistance. Here the resistance is present. The resistance of a conductor is very less. That means the opposition to the current is less. So it can be here easily current will be flowed. Okay. So here the resistance is less. For this R is very less. R is here very less means the current will easily flow. That means it is a good conductor of electricity. For example, copper wire, aluminium wire and almost all the metals. Almost all the metals are good conductor of electricity because the resistance is very much less. And there are free electrons present. Already told in first class, there are free electrons present which are the charge carriers. So because of that, all metals are good conductors. In almost all the metals, there are free electrons. Those free electrons carry the charge, hence the flow of electrons happens. Flow of electrons nothing but it is the flow of current. And the resistance of this is very less. Next comes insulators. Insulators means what? They do not conduct electricity. The resistance of insulator is very much high. The resistance of insulator is very much high. The resistance of conductor is very much less. Since the resistance is very much high, they highly oppose the flow of current. And there are no free charge carriers. This is why the insulators do not conduct electricity. For example, glass, paper. These all are the plastic examples of insulator. And third one comes semiconductors. Semiconductors are the one which conduct electricity sometimes and does not conduct electricity other times. Means the conductivity of these materials are in between conductor and insulator. Okay, here the resistance can be increased or even can be decreased. Okay, depending upon the situation of the electric circuit, the conductivity can be increased or decreased. Semiconductors are those materials whose conductivity is in between conductors and insulators. For example, silicon, germanium. These are examples of semiconductors. Insulators you know. Example is paper, then glass, plastic. These are examples of insulators. What about conductors? All metals. All metals are good conductors of electricity. So these are conductors, insulators and semiconductors. Okay. In conductors, R is less. I am telling because of considering R. R is less here. Means resistance is less. Resistance is here very high. More. Okay. And here it is medium. In semiconductors. Okay. In semiconductors, we can increase the resistance or decrease the resistance. Okay. And after this, resistance is inversely proportional to current. We came to know that. Resistance is obviously inversely proportional to current. We came to know about that. The current is increased, resistance decreases in the circuit. Resistance increased, current decreases in the circuit. See, Resistance, how it is represented? As already told in the electric circuit, I told you resistance will be indicated like this. This is our resistance. Resistor of resistance R. Okay? This is our resistance. In this way, we represent the resistance. Another resistance will come, we say it as a variable resistance. Sometimes in an electrical circuit, we represent like this, or we can represent like this. Okay, these two are variable resistance. Okay, or these two are variable resistance. So variable resistance means in the circuit the resistance can be varied. It can be changed by using the instrument rheostat. This question will be asked in most exams. So which is the instrument used to change the resistance? You have to remember this. Rheostat. Rheostat is the instrument used to vary the resistance in the circuit. In the circuit, if the resistance needs to be changed, in some circuits, there is a need of change of resistance. Some resistance needs to be changed so that current can be varied, so that we get the desired output. So that time resistance has to be changed. That work has to be done by this rheostat. This rheostat changes the resistance. Okay, so it can be varied. So this is the symbol of variable resistance. These two are the symbol of variable resistance. But this is the constant resistance. Symbol of constant resistance. Okay, so this is regarding resistance. Rheostat is important. This is the instrument used to vary the resistance in the circuit. Okay, then this is regarding you understood what is resistance and which instrument used. SI unit of resistance. Ohm is the SI unit of resistance. You should not forget. Representation should be like this. What is SI unit of resistance? SI unit of resistance is ohm, and the representation is like this. And factors on which resistance depends. We'll move to the next concept. Factors on which resistance depends. Factors on which, okay, resistance depends. Factors on which resistance depends. So for this, I will just tell you one experiment. Okay, suppose this is a battery or a, you can say, cell. Wire is there. Okay. See here, I will connect an ammeter. Ammeter I will connect just because to measure the current. What is the purpose of ammeter? It is the device used to measure electric current in the circuit. So how is the direction of I here? I will be always from positive to negative. Okay, conventional flow of current is from the positive terminal of the battery to the negative terminal of the battery. So this is our circuit. So here the conductor is present. This is our conductor. Suppose if I put a wire of length L, let me say a wire of length L. Say it is a nichrome wire. Okay, this is our first condition. So current is start flowing. The reading of the ammeter is noted. So nichrome wire in first case I is noted. First case I is noted. Nichrome wire of length L. Second, what I will do? I will replace this. I will replace this with Same nichrome wire, but the length is double L. Okay, here is L, there is also 2L. So same nichrome wire of second case is replaced by double length. This time also I is noted down. But remember, here what happens? Length is doubled, means current is decreased here. Okay, current is what? Decreased here. So I gets I by 2. The initial current become half of the current when length is double. Third time what I will do, see, just I am giving example here, nothing will be in this circuit. Third time what I will do, this I will replace this with thicker wire. Same length L but thicker wire. Third time nichrome wire only, but it is thicker. That time what will happen? Thicker means area of cross section will be more. That time current will become increases. It becomes 2I. And lastly what I will do? I will replace everything with, instead of nichrome wire I will put copper wire. Different wire at the fourth time. So what it comes? There will be a change in variable I. We cannot say that it is increased or decreased, but there will be a difference depending upon the nature of the material. So depending on these things, we come to know that, we have to know that. So this is all regarding I. So when I increases, resistance decreases. When resistance increases, I decreases. So what happened when the length is doubled? Current decreased. That means resistance increased. So resistance increases when length increases. So we call it as directly proportional. When resistance increases, length increases. Why? Because when length increased, current decreased, right? When length increased, current decreased means resistance increased. Decrease of current is nothing but increase of resistance. Okay, so length doubled, length increased means resistance also increases because here current decreased. So length and resistance are directly proportional. Similar way, thickness means area of cross section. Suppose this is a wire. Okay, this is length, whereas this is area of cross section. Okay, when area of cross section increased, current increased here, that means what? Resistance decreases. That means R is inversely proportional to the area of cross section. And third one is copper wire. So here nature of the material we have to understand. Nichrome is a different wire, copper is a different wire. So the nature of the material changes here. Nichrome has a different nature compared to copper. So that times also current varies. That means resistance also varies. So depending on this, we have to come across R is directly proportional to L, R is inversely proportional to A. So the three things where current factors on which resistance depends. What are the three factors on which resistance depends? First one is length of the material. First one is what? Length of the material. How it is connected to length of the material? Directly proportional. Resistance is directly proportional to the length of the material. As the length of the conductor or material increases, resistance increases. Second one, so instead of material we say conductor. Length of the conductor or material. Second one, area of cross section. Area of cross section of material, or say you say conductor. Conductor. In bracket we can say. Okay, here we say material or conductor. Length of the material, area of cross section of material, and third one is nature of the material. nature of the material or conductor. Or we can say conductor. So these are the three things. This question will be asked for 2 marks. List the factors on which resistance depends. Length of the material, area of cross section of the material, and nature of the material. These three things must be understood. Nature of the material. Okay. So these are the three factors in which resistance depends. Resistance of a resistor depends on these three factors: length of material, area of cross section of material, and nature of material. Okay. Now we look here. R is directly proportional to L there. So R is directly proportional to L by A here. That means not L by A, this is 1 by A here. Okay, inversely proportional it is. This is directly proportional, this is inversely proportional. Directly proportional means as R increases, L increases. They are inversely proportional. As R increases, A decreases. So including these two, I will write it as R is proportional to L by A. So this proportional symbol I will remove. R equal to L by A. But as I am told, when proportional symbol replaced by equal to symbol, then there must be a appearance of constant on the right hand side. So here the constant will come. We call it as rho. R equal to rho into L by A. Note down this please. This is called rho. How you have to say it as rho. R-H-O. Rho. You should not write it. Just pronunciation purpose I am telling you. You have to say it as rho. Rho. R equal to rho into L by A. This is very much important formula. R equals to rho into L by A. This is very much important formula. So what is rho? Rho is called specific resistance or resistivity. Don't get confused. R is resistance. L is length of conductor. Resistance of conductor. Area of cross section of conductor. Rho is resistivity of the conductor of material. Resistivity it is. Or in other words, we can say specific resistance also. This is resistivity. Okay. This is resistance, resistivity, length and area of cross section. Okay, we will see little bit about resistivity here. What is resistivity then? Okay. R is equal to rho into L by A. R is equal to rho into L by A. Then what is this rho is? Rho is resistivity. Okay. So how to define this? So when you have to define this, keep all the things as 1. R is equal to rho. When L becomes 1 and A becomes 1. Now define this. Wait for a minute. Now we will define this. Resistivity is nothing but the resistance of a material whose length is 1 unit and the area of cross section is 1 unit. Resistivity is nothing but the resistance of a material which is having 1 unit length and 1 unit area of cross section. Okay, that one will write. Resistivity is the resistance of a material. Resistivity is the resistance of a material whose length is unity and the area of cross section is also 1 unit. Area of cross section is also 1 unit. Area of cross section is also 1 unit, whose length is 1 unit and area of cross section is also 1 unit. This is called resistivity. Okay, so this is regarding resistivity. And what is the SI unit of resistivity? SI unit of resistivity is ohm meter. Remember, SI unit of resistivity is ohm meter. We can say like this, ohm meter. SI unit of resistivity is ohm meter. Remember, SI unit of resistivity is ohm meter. SI unit of resistance is ohm. Resistance can be changed, but resistivity cannot be changed. For a material, resistivity is fixed. For one material, if you take silver, for its resistivity is fixed. You cannot change the resistivity of a material. You can only change the resistance of a material by varying the rheostat. By changing the rheostat, you can change the resistance of a material, but it is not at all possible to change the resistivity of a material. It is fixed for a material. For a material, resistivity is constant. It is fixed, or we call it as specific resistance. It is fixed. We denote it by rho. Rho is the resistivity or specific resistance. What is its SI unit? Ohm meter. How to pronounce? Rho. Ohm meter. So defined resistivity. Resistivity is nothing but the resistance of the material having unit length and unit area of cross section. Or you can say resistivity is the resistance of material whose length is 1 unit and area of cross section is also 1 unit. This is called resistivity. So today in this class we have learned all about this. Okay, and just I want to tell you one thing about the second class. I have represented one diagram like this, but in that diagram just I want to change. I want to note it down. Only one change was there. So I represented a key like this, or a switch we can say, but it should be always closed. It means we have to be put one thing. Unfortunately, I forgot that. Okay, we have to be put a sign like this in this middle, so that key should be closed. Otherwise, there will be no flow of current. That is why key should be closed. Only that thing you have to remember. Everything is fine. Remaining everything is fine. Only this should you know that key must be closed in an electrical circuit. Then only current will start flowing. Okay. And obviously from plus to minus the current flow will be there opposite to the flow of electrons, because that is a conventional flow. Okay. Then what is switch? I want to tell you what is switch. Switch is the link between battery and bulb. If I put a bulb here, this is bulb and this is battery or supply. Switch is the link between battery and bulb. Okay, a battery, bulb and supply. Battery is also sometimes called as a power supply because voltage is coming from battery only. So this is regarding the total class. So we learn what is resistance, factors on which resistance depends, what is resistivity. Okay, we all come to know about this. Understood? Okay. This is regarding total resistance, resistivity and factors on which resistance depends. SI unit of resistance is ohm. SI unit of resistivity is ohm meter. You have to remember all these things, and Ohm's law also you have to remember. Okay. In the next class, we'll learn about resistivity of materials and with some problems. Okay. We'll learn in the next class. Okay, we'll stop today's class here only. In the next class, we'll learn about resistivity of the materials. That means their values. Here we learn about definition and all. Next, we'll learn about their values. And after that, we'll have problem sessions. Okay, please go through this.